On problem number 1, we are finding all the real roots. So I'm going to factor 100 and I get 10 times 10. I factor 10 and I get 5 and 2, 5 and 2. So I have a set of 2's, and I have a set of 5's. I am going to take out, my index is 2 because it's not shown, so I'm going to take out sets of 2. So that's how I got 2. I take out this set of 5's, that's how I got 5. And this says all the roots. So 2 times 5 is 10, and then I get plus or minus. On problem number 2, I'm finding all the roots. So I factor 49, and that's 7 and 7. I have 2 numbers after the decimal, that's how I got 0.7. My index is not shown, so it's 2. I'm taking sets of 2 out, so I have 2 0.7s. That's how I get plus or minus 0.7 because it said all the roots. In problem number 3, I'm going to simplify. So I'm going to factor 36, 6 and 6. I'm going to factor 6, 2 and 3. So I have a set of 2's that came out. That's how I got that 2. I have a set of 3's that came out. That's how I got that 3. I have a set of x's that come out. So I get 6x. Now I need to use my absolute value rule. My index in the original problem is not shown, so it's even. It's 2. My power is 2. I got an odd answer, x to the first power. I have to use the absolute value to make that true. In problem number 4, my index is 3. I am going to first factor 8. I get 2 times 2 times 2 is 8. I have 3 numbers after a decimal, so I made them all 0.2. When I multiply them, I get 0.008. So that's how I got 0.2, 0.2, 0.2. I am going to write out y cubed in longhand. There is a shortcut, and I hope you see the shortcut. And then x to the 6, I wrote it out in longhand, but there's a shortcut. So I am looking for sets of 3 because that's what my index is, 3. I'm looking for 3 sets of 3 to come out. So that's how I get the 2.2. That's how I get y and x and x. So this is what I got for an answer. I do not use the absolute value rule because my index here is odd. In problem 5, my index is 2. So I'm going to factor 50. I get 25 times 2. I'm going to factor 25, 5 and 5. So I got a set of 5's. So that's how 5 came out. 2 does not come out. 2 stays under the radical. Then I wrote this longhand. I have a set of x's and another set of x's. That's how I got x squared. Then I have y to the 8th. I wrote it longhand, so here are my sets. That's how I got y to the 4th. If I check my absolute value rule, I don't need it here. In problem number 6, my index is 4. I'm looking for sets of 4 to come out. I'm going to factor 32, 2 and 16. Factor 16, 2 and 8. I factor 8 as a perfect cube. That's how I got all of these 2's. I am going to write my m to the 7th in longhand, so there's my m to the 7th. I am going to write n to the 9th, so here's n to the 9th. I hope you're using the shortcut to make this easier. I am looking for size of 4 to come out, so I have a set of 2's. That's how I got that 2. I have a set of m's. That's how m came out. I have 2 sets of n's. That's how I got n squared. The rest of them did not come out. That 2 didn't come out. That m cubed didn't come out. That n didn't come out. In problem number 7, I'm going to multiply these. I have the same index, so I can multiply. First, I'm going to factor 4. I got 2 and 2. So under the radical, that's how I got those 2. I'm going to factor 9. I get 3 and 3. That's where these 3's come from. Outside of the radicals are 6 and 2. They stay outside as 6 and 2. Then I go ahead and look for my sets. I have a set of 2's. That's where that 2 came from. I have a set of 3's That's where that 3 came from. Then I have x, and I have x, and I have y. Everything came out of the radical. So when I multiply them all together, I get 72, except I need to check my absolute value rule. In my original problem, I have even index, even powers, but when I multiply this, my y becomes the first power, so that's odd, so I need absolute values. In problem number 8, my index is 3 on both of these, so I can go ahead and multiply them. I'm going to go ahead and factor 9, and that's how I got these 3's. I am looking for sets of 3's to come out. So I have one set of 3's. That's where that 3 came from. This 3 stays under the radical. And I don't need to use absolute values because my index is odd. In problem 11, I'm looking for my index is cubed on both of these. So I'm going to go ahead and divide them. First, I'm going to factor 64. That gives me 8 and 8. 8's a perfect cube. 2 times 2 times 2. So that's where I got all these 2's. And I hope you know the shortcut. But if you don't, I'm writing this out by longhand. I have x to the 9th, so I wrote out x to the 9th. I have y cubed, here's y cubed. In my denominator, I factored 8222. That's where these 2's come from. And then I have x cubed. Next thing I need to do is I need to reduce. I notice these 3 2's cancel out these 3 2's. These x's cancel out these x's. My index is 3. I am looking for sets of 3's to come out. So that's how I got 2 to come out. Then I have 2 sets of x's. That's how I got x squared. And I have a set of y's that came out. That's how I got y. In problem number 12, I am going to subtract. I notice right away I could factor 81 to 99. And then 9 factors to 3. I can factor 24 to 8 and 3, and then 24 to 2, 2. So 10 is not under the radical, it stays not under the radical. My index is 3, I'm looking for sets of 3's to come out. That's how I got that 3. This 3 stays under the radical. And then I have a set of 2's that came out. That's how I got that 2. This 8 was never under the radical, stays not under the radical. This 3 stays under the radical. Now notice I have the cube root of 3 on both of these terms. So I'm going to go ahead and multiply these two together. That's how I got 30. And then 8 and 2 is 16. I'm going to find the difference. There's my difference. In problem 13, I want to simplify, and I notice I have a radical in the denominator. I need to get rid of that radical. So to make this easier, I'm going to put parentheses around this problem. And I want to multiply it in the denominator by the conjugate. If I have minus, I'm going to multiply it by plus. Those conjugates have no middle terms. So when I multiply this, I am going to go 4 times 4. That's where I got 16. And then the square root of 12 times the square root of 12, that gets rid of the radical. That's how I got 12. So in my denominator, I get 4. My numerator, I am going to go ahead and do FOIL. So I'll do my first terms. So I'm going to multiply those together. That's how I got 16. I'm going to do my outer terms. So I got plus 4 square root of 12. And then I'll do my inner terms. So I got plus 4 square root of 12. That's how I got 8 square root of 12. And my last terms, square root of 12 and square root of 12, is how I got 12. So I'm going to go ahead and combine like terms. So 16 and 12 is how I get 28. And my middle term is 8 square root of 12. And I notice right away that 28, 8, and 4 all divide by 4. That's how I got 7 plus 4 square root of 3. In problem number 14, I'm going to subtract and I'm going to add. And I notice 48, 27, and 75 all can be factored. So I'm going to go ahead and factor 48, 16 times 3. I'm going to factor 16, 8 and 2. 8's a perfect cube, 2, 2, 2. So that's how I got 4 2's and a 3. Then I'm going to factor 27, 9 and 3, and then 3 and 3. That's how I got 3, 3, 3. Notice this 3 is not under the radical, stays not under the radical. That's why it's right there. I'm going to factor 75 is 3 times 25, then 5 and 5. So that's how I got 5, 5, 3. This 2 is not under the radical, stays not under the radical. I am looking for sets of 2's to come out. So I have 2 and 2. 3 stays under the radical. That's how I got 4 square root of 3. I have a set of 3's that come out, multiplied by that 3. So 3 times 3 is 9. So that's how I got 9 square root of 3. And I have a set of 5's. 2 times 5 is 10. And then I'm going to go ahead, 4 minus 9 plus 10. That's how I got 5 square root of 3. In problem 15, I'm going to multiply these two binomials with a radical. So I'm going to do my first term. I'm going to go 3 times 1. So I got 3. I'm going to do my outer term, 3 times square root of 7. And then I'm going to do my inner term, 1 square root of 63. And then I'm going to do my last terms. So square root of 63 times 7. That's how I got this. And I'm going to factor, because I notice right away I can factor 63 to 9 and 7, so then I get 3 and 3. So under the radical, I get 3, 3, 7. I'm going to factor 63. I see I get exactly the same answer, but 7's under the radical. So I get 3, 3, 7, 7. My index is 2, so I'm looking for a set of 2 to come out. So that 3 comes out, so that's how I get that 3 square root of 7. I have a set of 3's and a set of 7's, so I get 7 times 3, that's I get 21. So I'm going to combine like terms. That's how I got that answer. In problem 16, I'm going to simplify this. I notice I have a radical in the denominator. I need to get rid of the radical. So I'm going to factor 6. That's 2 times 3. So I have a 2 and a 3. I have y cubed. I'm going to write this out longhand. So I have y, y, y. I have square root. So I notice right away I have a set of y's. That y comes out. So I want to get the 2 out and the 3 out. So I have 1, 2, so I need to multiply it by another 2. I have 1, 3, so I'm going to multiply it by another 3. And I have 1 y, so I'm going to multiply it by y. So I'm really using the identity property here because this equals 1. I'm not changing the value. So I'm going to go ahead. I have a set of 2's that come out. That's how I got that 2. I have a set of 3's that come out. That's how I got that 3. I have a set of y's that come out. Now that's how I have that y. In my numerator, nothing comes out. So I get x, 2, 3, y. And I multiply all those together. They're all still under the radical. That's how I got this answer, which does not reduce.